Hello everyone. Today we are going to start with the concept of banking of roads. So the first thing that comes in my mind is what are banked roads? And then the second question should be like why do we construct banked roads? So like what was the need of constructing a banked road if you can have a flat road and the vehicle can move in that circular path, right? So the banking of road means that the outer edge of the road is elevated a bit as compared to the inner edge of the road. And then suppose you're moving in the circular path. So for example, you don't have a banked road and you're moving in the circular path on a flat surface. So you know that for the circular motion, the force required to move it in the circular path is centripetal force, and this force is provided by the friction produced by the tires of the vehicle. So now, but the two main problems that we may encounter during this motion is that, so for example, the coefficient of friction is not that high, and or you can say the road is wet or icy, then the friction force will be really insufficient, and there are dangers of accident because the vehicle will skid, right? But another problem is that even if you have very high force of friction, like very rough surface, then also vehicle may roll over. The reason is that whenever a car is moving in a circular path, the tires of the car will produce a net moment about the center of mass, and this may cause the vehicle to roll over. So to avoid this situation, we construct banked roads in which the outer edge is raised slightly upwards and the inner edge is not raised. It is at the ground level. Now here, as you can see that in this situation, you can see two or three players which are going on the banked road. So you can see in this there is the outer edge which is raised or elevated a bit upward as compared to the inner edge, right? So I'm going to show you, this is my side view of the banked road. So this is the outer edge, this part which is elevated a bit upward, and this is the inner edge, right? So now the angle by which the outer edge is raised is known as angle of banking. Okay, now my first priority is to look for all the forces that are acting on this car. So obviously the weight of the car will be acting vertically downwards. Now for the normal reaction force, remember one thing, this normal reaction force is always perpendicular to the surface. So this is the direction of normal reaction. Now the force of friction is going to provide the centripetal force, and it acts in the downward direction towards the inner edge, right? So there are three forces which are acting on this car. Now I'm going to resolve all the three forces that I have already determined into their horizontal and vertical components. So look here, the first force is in the vertically downward direction, so I don't have to resolve it because this is the vertical component of weight. The weight itself is in the downward direction. Now this is my normal reaction force which is acting perpendicular to the surface. Now look here, I'm going to draw this dotted line over here. If this angle is theta, which is, let's say this is angle AOB, if angle AOB is theta, then angle, let's say this is C, and let's say this is D, so angle CDO is also going to be theta. Fine. Now look here, if this angle is theta, the reason behind this is that they are alternate angles, right? This is equals to this, right? Now let's just draw a dotted line over here, right? If this angle is theta, then by applying simple mathematics, this angle also turns out to be theta. Now I'm going to resolve this normal reaction force into horizontal and vertical components. So this is theta, and this component is the vertical component, which would be nothing but n cos theta, and this is the horizontal component, which is nothing but the n sine theta. Now another force that is acting along the plank of this road is force of friction, which is denoted by small f, and And again, if this angle is theta, then this component of force of friction would be F cos theta, and the component acting in the downward direction for the force of friction is F sin theta. Now next step is to determine the forces in the vertical direction. So in the upward direction you have n cos theta, and because the object is not, there is no net movement in the vertical direction, so obviously all the forces are equal and opposite. Like the upward force is equals to total downward force, which is nothing but mg plus F sine theta. So I would rearrange this equation, and I'm going to get mg equals to n cos theta minus F sine theta. So let's just mark this equation as equation number 1. Now consider the vertical components, not the vertical, sorry, horizontal components. So as you can see that you have n sine theta and F cos theta towards the center of the circular path that is being traversed by this object, right? So this, the sum of n sine theta plus F cos theta are responsible for the centripetal force, which is nothing but mv square by r. So now I have again rewritten the equation number 1 and 2. Now force of friction is nothing but mu times normal reaction. So because over here we are talking about static force of friction, so I'm going to take static coefficient of friction, which is mu Sn. So what I'm going to do is I'm going to replace this force of friction by mu times n. So I'm going to rewrite my equation 1 and 2. So this is n, the first equation becomes n cos theta minus mu Sn sine theta, right? And the second equation becomes mv squared by r equals to n sine theta plus mu s times n cos theta. So let's just divide this equation, the equation number 4 by 3. So when you divide that, you'll get v square by rg equals to n sine theta plus mu s n cos theta divided by n cos theta and minus mu s n sine theta. Now you can analyze that n is common in every term. So what you can do is take out n common from numerator and take out n common from denominator as well, and they'll get cancelled. So the equation is going to become sine theta plus cos theta with a mu s over cos theta minus mu s sine theta. This is equals to v square by rg. So you can calculate the safe limit of speed while moving on the banked road using this equation number 5. So what we have done so far is that we have understood the concept of building banked roads, that is just to prevent the accidents and to prevent the vehicle to skid or roll over, right? And then we did the free body diagram of all the forces acting on the object, which were namely 3 forces. First was the weight, then normal reaction, and then force of friction. And then we balanced the, and then we what we did was split the forces into the horizontal and vertical components, and then we worked out with the equations to get the formula involving speed of the vehicle moving on the banked road. So you can use equation number 5 to find this v for the vehicle. I hope you guys liked the video and understood the concept about banking of roads. So if you guys understood, please press the bell icon button and subscribe to my channel for more upcoming videos on circular motion, and then we will be doing electromagnetism. So till then, stay safe and stay happy. Thank you.